So thank you very much. Happy to be here. My name is Naranjo, and I'm from Discover Financial Services. And I'm here to do a presentation on managing Terraform Enterprise with 2,000 plus workspace at Discover Financial. So to get started, you may be wondering to yourself, 2,000 workspaces seems like a lot of workspaces. How exactly do you go about managing so many workspaces and infrastructure? The idea is that you want to make sure you're asking the right questions. When you're managing so many workspaces, the workspaces have over 2,000 state files, including all your key infrastructure. So the idea being here at Discover, we use Terraform and the Terraform workspaces to manage our public cloud infrastructure, including GCP and AWS. The idea being with all this key infrastructure, these state files hold a lot of sensitive information, and you want to make sure that when you're managing Terraform Enterprise, you have no unanswered questions. The idea being that you want to make sure everything is secure and managed properly, since these state files are very critical to your organization. So to get started, I want to do a quick overview of the type of questions I'm going to be going over in today's presentation. We're going to be starting off very big with the idea of managing Terraform Enterprise itself and going down very small to the actual workspace, at the actual workspace level. So how exactly do you manage Terraform Enterprise? You have to make sure that your environment is set up properly to make sure all the workspaces that are being created within Terraform Enterprise are secure. So to do this, we're going to look at two things: the Terraform Enterprise architecture that we have at Discover Financial Services, and how exactly do we handle the disasters in case something happens. So if you see here, this is the architecture that we have currently at Discover Financial. For us, we decided that it would be best to deploy our infrastructure within AWS. And if people are familiar with Terraform Enterprise, this is very similar to what is recommended by HashiCorp. So we always try to follow what's recommended by the vendor to make sure everything's managed properly. So going on to the disasters themselves, you want to take into account two different things. At Discover, first thing we want to take into account is the availability zone. In AWS, the EC2 instances are within one single AZ. So we want to make sure in case that AZ goes down, we're able to redeploy the EC2 instance in a different AZ to make sure that we have the workspaces available. Since with 2,000 plus workspaces, that's a lot of teams, that's a lot of resources. So we have to make sure that these workspaces are available to all of our users. Secondly, and more importantly, is how do we handle region disasters? The idea being that this is a bit more of a major situation, and we want to make sure that our workspaces and the state files themselves are available when a region goes down. The idea being, the way we set it up here is we do two things: RDS read replicas to make sure that the workspace and the workspace name, the metadata of the workspace, is available in another region in case one region goes down. So we're actively transferring over all the data to a replica in a new region. And secondly is the S3 bucket. The idea being within your Terraform Enterprise environment, all the state files are stored within an S3 bucket, and you want to make sure that you utilize S3 replication to actively be moving these state files into another region. So everything is good right there. We have all of our data available in another region, but that data is going to be useless if we don't have a way to actually redeploy Terraform Enterprise in another region quick and successfully. So we want to make sure, how do you actually go about making sure you deploy your Terraform Enterprise environment in a quick and successful manner. In case a region goes down, you're able to easily have your workspaces be available to be consumed. And to do this, we have a deployment automation set up. The idea being is that at Discover, we set up a Jenkins pipeline where all of that does Terraform commands. The idea being all of our Terraform enterprise infrastructure is managed by Terraform. And this pipeline is set up that you first generate a plan of all the infrastructure you want to recreate. So if you looked at, remember from the architecture, that's recreating the Route 53, the EC2s, the load balancers. So the idea is you generate a Terraform plan, and before you move on to the actual apply, our pipeline is set up in a way that we actually want to scan the actual state plan itself. We want to make sure that whatever the engineer is redeploying is secure. The idea being, let's say, for the S3 buckets, we want to make sure those are encrypted. And not only the S3 buckets, but make sure the EBS volume and the RDS is encrypted itself. And only when all these infrastructure is properly configured and properly encrypted, our Jenkins pipeline allows us to move on to the next step, which is the Terraform apply. The idea being that our pipeline checks to make sure everything is good, and then it actually deploys our infrastructure within AWS. And here, two things happen. The state file is stored within a separate S3 bucket, and then all the infrastructure gets deployed in AWS, including the Route 53 table, the RDS bucket, S3, and finally the EC2 instance. And when the EC2 instance gets created, this triggers a chef cookbook. The idea being that we just don't want to automate the creation of Terraform Enterprise. We want to make sure that we automate the actual deployment of the Terraform Enterprise application. So the chef cookbook gets triggered when the EC2 is created, and that creates that gathers all your files, the air-gap files, the replicated files of your Terraform Enterprise environment, and it actually deploys it within the EC2 instance. So as soon as you trigger the pipeline, at the very end, your EC2, your Terraform application is available to be consumed. So let's go back a little bit. Go back to the actual scanning of the Terraform plan. What happens in case the actual plan detects something that it doesn't like? Let's say the S3 bucket is not being encrypted. The idea is that we set up our Jenkins pipeline to make sure that if that indeed does happen, then the pipeline fails. With so many workspaces and so many state files containing a lot of sensitive information, we want to make sure wherever we deploy our Terraform Enterprise application is as secure as possible. So that's why it's very important that we have fail-safes in place in case the engineer forgets to encrypt their S3 buckets or the RDS database, that it doesn't let them actually create it. So this is what is done. As a quick overview, this is a quick recap of what happens on your first deployment to a new region. Either the pipeline sees what it likes and deploys the infrastructure within AWS, or it sees something that's not configured properly and it fails. But that's just the first deployment, and that's make sure the actual infrastructure is very secure. But that's not the only thing that we have to be checking to make sure it's secure. So for any subsequent deployments, we add just an extra step at the very beginning, right before the Terraform plan, and this is a Terraform tin command. The idea being that we want to recreate this infrastructure on a monthly basis, or depending on your organization, a weekly, bi-weekly basis, such that the idea being that the EC2 instances are tainted, so we want to recreate them. We do this for two reasons. The two reasons are, the first one being the AMI. At Discover, we're always updating the AMIs that are being used for our EC2 instances, and these updates include security patches. So we want to make sure we're taking advantage of these security patches, since, as I keep mentioning, these state files are very critical at Discover, and they hold very critical information. So we want to make sure that there's no ways to get unauthorized access. So that ensures that our AMIs are secure. And secondly is the Terraform Enterprise application itself. As many of you might be familiar, Terraform Enterprise gets updates from HashiCorp on a monthly basis. And the idea being that we want to take advantage of these updates, whether it being security patches or actual new functionality to the Terraform Enterprise architecture. So that's why for every subsequent deployment, we want to make sure we are refreshing the EC2 instances and recreating them. So that takes into account where it comes to the Terraform Enterprise architecture. So now let's dive a little bit deeper. What about the Terraform Enterprise organization? The place where all the workspaces are going to be living in. So the way we set it up is a single organization within Terraform Enterprise with multiple teams. The idea being that we want all of our teams to live in one environment, and they manage their own workspaces, where each team has access only to their workspace, and they just live within the same organization. The reason we went through a single org multi-team structure is that we want to take advantage of two things offered by Terraform Enterprise. Firstly being the Terraform module registry. The idea being that at Discover, we have teams that create Terraform modules for all the Terraform code, either for AWS or GCP, and we want to make sure that our teams are utilizing those Terraform modules when creating their infrastructure. The idea being some teams may not be super familiar with Terraform, so we want to make it as easy as possible for them to be able to consume Terraform. And secondly is the Sentinel policies. So the idea being with Sentinel is that we want to make sure that when infrastructure is getting created through our public cloud providers, that we set some guardrails. And the idea being with so many teams at Discover, a lot of infrastructure is going to be created, EC2s, Lambdas, and it's hard to keep track of all this infrastructure that's being created. So the idea is with Sentinel, we have policies such as mandatory tagging. We want to make sure that when people are creating infrastructure with Terraform and deploying it through Terraform Enterprise, we want to make sure that each resource is tagged properly, including the team name, the cost center, and for example, like the team email. So we want to make sure that in case something happens, we know who owns what infrastructure within our cloud environment. So that's very good, but we have to take into account, if you notice from the Workspace organizational structure, all these teams live in a single org, so how do we handle the team permissions within those workspaces within that single org? So you may have noticed that we separated into 3 different sub-teams per team: read-only, developer, and owner. The idea being for read-only is that there might be some times where someone wants to audit someone's workspace, and we want to give people access to be able to read the state file, read the variables within the workspace itself, but not make actual changes to the workspace. So the TFE read-only is what they would be given access to. And secondly is developer. So this is where most of the developers and engineers for a certain team will have access to. The idea being that the developers are the ones that are constantly making changes to their Terraform code and redeploying the infrastructure. So we want to give them access to be able to do runs and applies within Terraform Enterprise. And lastly is owner. So the idea being with owner is that even though we have developers that make changes to the workspace, we don't want them to be able to just delete the workspace. These state files are very key to Discover, so if they delete these workspaces, they could really cause issues at Discover Financial. So the idea being we have this separate team of owner where only a select few people per team should be given this access to give actual changes to the actual workspace configuration itself and give access to delete the workspace in case it's no longer needed. So this is all good and everything of now we have multiple teams in the Terraform organization, but how do we onboard more teams? We want to attract more teams to start using Terraform Enterprise instead of just Terraform open source. So we want to make sure we have a simple and simplified process to onboarding teams. So the way we set this up at Discover Financial is we have a simple form that the users fill out, including their team name and the team owner. And once they fill out this form, it gets sent to like a Jenkins pipeline. And this pipeline does the actual team creation via Python. The idea being that in Python, we create the TFE teams and the LDAP groups that are associated with them. And you may have noticed under the Python symbol, we have something called the TFE SDK. At Discover, we have this custom Python module set up as a way to interact with the Terraform Enterprise API. The idea being this Terraform Enterprise offers an API to create workspaces, create teams, and we want to be able to easily add these functionality to our workspace, to our pipelines. The idea being that most of our developers are used to programming in Python, so we developed this custom module to do a lot of the Terraform Enterprise APIs. I'll be going more into this a bit later, and you'll be seeing this TFE SDK as we go on through the presentation, but this is just something to keep in mind. So lastly, when we create the Terraform teams through this TFE SDK and the LDAP groups, the idea being that each team is associated with a specific LDAP group. The idea being, let's say the read-only has a read-only LDAP group, the developer has a developer LDAP group, and so on and so forth. The idea being that we have these teams created, and the way we give access to these teams is such that the user has to request access to the LDAP group itself, and once they have access to this LDAP group, they are automatically added to the Terraform Enterprise team. So this makes it a simplified process and an automated way for users to get added and removed depending on what LDAP groups they have within the organization. So this is very good, and now we have multiple teams within Terraform Enterprise, and multiple teams are now getting onboarded to Terraform Enterprise, but this might cause a lot of workspaces to be created. As I mentioned in my title of my presentation, there's over 2,000 plus workspaces currently within Terraform Enterprise, and now that we have such a simplified process to add more teams, more workspaces are just going to keep being created. So how do we exactly manage the workspace creation process? So for the workspace creation process, we do what's recommended by HashiCorp, and you want to take into account 4 things: volatility, blast radius, access needs, and common configuration. The idea being that you each have to take into these things all these 4 things into account whether you want to create a new workspace or make the resources that you want to create as a part of an already existing workspace. The idea being, for example, volatility, we want to take into account how often is this resource being updated. If it's resource being updated like on a daily basis or very often, we don't want to put it in the same workspaces with other resources that are not updated as often. Secondly is, for example, blast radius. The idea being that some resources are very critical to your cloud infrastructure. So you want to make sure if these workspaces are very critical that you don't want them to be able to, if they're destroyed, they will have a big blast radius and they'll damage a lot of your infrastructure. So you want to make sure these are separated from other resources. And thirdly is access needs. The idea being that you might want to recreate this whole application, but it includes multiple parts. And the idea being here is that maybe your engineer should only have access on creating certain parts of the infrastructure and not other parts. So the idea is that when you take into account access needs, you want to make sure that the resources per workspace is all the engineers should have access within that workspace for those specific resources. And finally is common configuration. Some resources and some infrastructure within AWS and GCP are just going to be recreated. We want to make sure those resources are going to be commonly used for different environments. So we want to make sure that those resources are their own separate workspace. So these are the 4 things that you need to take into consideration when creating your Terraform workspaces. And only when you take those 4 into consideration is whether you decide whether you want to create a new workspace or you should be reusing an already created workspace to add more infrastructure and resources. So that's very good, but how exactly do you handle the stale and old workspaces? The idea being we want to make sure we manage properly when workspaces are created, but over time, some of these workspaces are no longer going to be used. They delete all their infrastructure, but they don't delete the workspace. Or maybe a team is just testing how to create workspaces, and they create a couple of test workspaces that are just clogging up your environment. So you want to make sure you have a clean and simplified environment within your organization, especially if you're managing over 2,000 workspaces. So for this, we have a cold storage process. And the idea being is we want to take into account when we want to delete workspaces that are no longer being used. The idea being here is we decided on a 2-year policy. If your workspaces haven't been updated or touched in 2 years, then what my team will do is they will delete that workspace and store it within an S3 bucket to be archived. But we want to make sure that we exclude certain resources. The idea being that there's some workspaces that are holding key infrastructure that may not be updated on a daily basis, but they're very key to your cloud infrastructure, including the IAM policies, VPCs, and networking. So you want to make sure for any automation you have for cold storage, you want to make sure there's a way to exclude certain infrastructure. And this is just like a general list. Maybe one team might come up to you and say, like, oh, we want to make sure that this workspace doesn't get deleted as well. So you want to make sure that you take into account this exclusion when you're putting workspaces into cold storage. So the way we go about actually putting these into cold storage is we have a custom Python script that utilizes this TFE SDK that I mentioned earlier that grabs all the metadata and state files from that workspace via the Terraform API. And once it gathers all this information from Terraform Enterprise, what happens is we compress all this information to a zip file and we upload it to the S3 bucket. The idea being that we just don't want to delete the workspace. We want to have it archived somewhere in case someone wants to reuse that workspace even though it hasn't been used for over 2 years. So that's good and all, but now that we have it archived, how exactly do we go about and retrieve the workspace? So you want to make sure you have a simplified process to actually retrieving the workspace to make sure that workspaces are archived if a team requests for them to be re-added back to your Terraform Enterprise environment, that you're able to do this in a quick and easy manner. So to do this, we have a cold storage recovery process, which is very similar to our cold storage process itself, where we utilize a TFE SDK to recreate the workspace. The idea being that we have a Python script that extracts your zip file from your S3 bucket and decompresses it. And then in there, you're going to see a lot of information, the workspace name, the Terraform version it's using, and all the state files. So this is where the SDK comes in. It grabs all that information, it recreates the workspace, and it adds all your state files to that workspace properly. And once that's all completed, it's added back into Terraform Enterprise as if it was never gone to begin with. And this is very important because we want to make sure that when we re-add the workspace, they don't have to change anything in their infrastructure to be able to start consuming it again. So it's very important to make sure the naming convention and the Terraform version is kept the same so it doesn't break anything in your customers' pipelines. So this is great and all, but this leads us all to our very last thing for this presentation is how do you handle dependencies? Throughout this presentation, I mentioned the TFE SDK throughout multiple different pipelines. And the idea is maybe in the future, when we're managing our infrastructure, we're going to be adding more pipelines. So the idea here is that we have this TFE SDK where we have all of our common code. We want to make sure that for all these pipelines we create for managing our infrastructure, we're creating it in such a way that we're able to reuse it in multiple pipelines. So the way we went about this is we made this custom Python module that we version when we have new updates and new functionality that we want to add to it. The idea being that some pipelines will be, a lot of pipelines will utilize this TFE SDK as ways to interact with the Terraform enterprise environment. And we want to make sure that in the future, we might want to create a new pipeline as another way to manage our environment. And we want to make sure that when we update this SDK, it doesn't negatively affect our already created pipelines. So we want to make sure when you have dependencies in code that's being used through multiple pipelines, you version it such that you create a new version for your newer pipelines, and your old pipelines are using older versions that they are unaffected. This is very important because when you're managing so many workspaces, you want to make sure that all your pipelines that you're using to manage these workspaces are unaffected. So this leads off to the very last thing, our key takeaways. So there's 3 things that I hope everybody learned, and I want to reiterate as a part of my presentation. First is customer feedback. As I mentioned, there's a lot of teams within Discover that are utilizing Terraform Enterprise. And because of this, they're going to keep giving you a lot of customer feedback. For example, one of the things that they will most likely give you feedback is on the workspace archiving and cold storage tool. So we want to make sure that you take that into account because that's very key to telling you whether you're managing your pipelines and your pipelines properly within your Terraform Enterprise environment. So if you're not properly archiving your workspaces, your customers will complain. Secondly is you want to experiment and conduct POC. So as I mentioned earlier, when we refresh our Terraform Enterprise environment, we want to make sure we're using the latest version of Terraform Enterprise as a way to get security patches and new features. And then the idea with experimenting and conducting POCs is the second point of the features. We want to make sure that when Terraform Enterprise adds new features such as run task or drift detection, we want to make sure that your team is taking advantage of them and is experimenting with these features to make them available for your customers to use. Because your customers will come back to you and say, I saw this new feature within Terraform Enterprise, how do I use it? So this is very important when you're managing your workspaces, as you want to make sure you keep all your customers happy. And lastly, but not least, is automation. Automation is very important when managing all these workspaces and managing the Terraform Enterprise environment itself. If you do not automate everything, that means you're running everything manually, and being able to run that manually is going to be a slow and tedious process, including, for example, let's say the refreshing process of your Terraform Enterprise environment. If that's a manual process, that could take up to 1 to 2 hours just to refresh your Terraform Enterprise environment instead of 30 minutes where if it's automated. And if that's the case, then your customers will complain and say, why can't I use Terraform Enterprise right now? It's down, it's unavailable to use, and that's something you want to avoid. And that being as well for your team creation is you want to make sure when teams are created, you want to make sure that entire process is automated. So the teams are created fast and they're easy to consume for your customers. No one wants to ask oh, I see Terraform Enterprise, I want to be a part of it. Let me ask to be onboarded to this team. And only for in the back end, one of your engineers have to manually create the team, and it takes 1 to 2 days for them to actually create this. And then the new customers that want to be in Terraform Enterprise are you know what, never mind, I'll just use open source instead. So you want to make sure that you're automating all your processes properly, and in the future, when you add new functionality as a way to manage all these workspaces, you want to make sure that's automated as well. And with that, I end off my presentation, and I want to say thank you. I hope everybody learned something new today, and I enjoyed my time here in HashiConf, and I hope you guys do as well. Thank you.